This is Professor Maria Luisa Bainyo Salingay, greeting you a pleasant day. I am glad that you are joining me in my short discussion on stoichiometry. Stoichiometry deals with relationship, quantities of reactants and products before, during, and after chemical reactions. To fully understand stoichiometry, you need to review the following: balance equation by inspection, concentrations of solution like molarity, molality, or normality, and mastery of the following terms like volume, mass, density, mole, or molar mass. Let us start with some review exercises. If this review doesn't work with you, I advise you to check on my earlier videos for the mastery of terms and concepts. So we'll start with number 1. What is the molality of a solution that contains 75 grams of sodium chloride and 300 ml of water? The density of water is 1 gram per ml, and the molecular mass of sodium chloride is 58.44 gram per mole. So the molality of the solution is equal to 75 grams over 58.44 gram per mole times 1 over 0.3 kilogram solvent. So the molality is equal to 4.3 m. Number 2. What is the molarity of a solution that contains 25 grams of silver nitrate dissolved in 800 ml of water? The density of silver nitrate is 4.35 grams per ml, and the molecular mass is 169.87 grams per mole. So molarity is equal to moles of solute over volume of solution. This is 25 grams over 169.87 grams per mole times 1 over the volume of silver nitrate and the volume of water. So molarity, or capital M, is equal to 0.182 mole per liter. Number 3. What is the molality of a solution in problem 2? Take note that the density of water is 1 gram per ml. So molality is equal to moles of solute over kilogram of solvent. This is equal to 25 grams over 169.87 gram per mole times 1 over 0.8 kilogram solvent. So molality, or small m, is equal to 0.184. Number 4. What is the percentage by mass of a solution that contains 25 grams of silver nitrate dissolved in 800 ml of water? The density of water is equal to 1 gram per ml. So the mass in gram is equal to 800 grams. Percentage by mass is equal to mass of solute over mass of solution times 100 is equal to 25 grams over 25 plus 800 gram is equal to 3.03 percentage by mass. Number 5. What is the percentage by volume of a solution in problem 4? Note the density of silver nitrate is 4.35 gram per ml and the volume is 5.75 ml. Percent by volume is equal to the volume of solute over volume of solution times 100%. So 5.75 ml over the volume of solution, which is equal to 5.75 plus 800 ml, is equal to 0.71% by volume. Number 6. What is the mole fraction of the solute in the solution that contains 25 grams of silver nitrate dissolved in 800 ml of water? The molecular mass of water is equal to 18 grams per ml and the density is 1 gram per ml. Molecular mass of silver nitrate is 169.87 gram per mole. So the mole of water is equal to 800 grams over 18 grams per mole is equal to 44.44 mole. while the mole of solute, which is equal to 25 grams over 169.87 gram per mole, is 0.147 mole. So the mole fraction is equal to the moles of solute over moles of solution, which is 0.147 mole over the moles of solution, which is 0.147 plus 44.44 mole. So the mole fraction of solute is equal to 0.003. No unit because you cancel out the mole. Number 7. What is the mole fraction of the solvent in the solution in problem 6? Mole fraction of solvent is equal to the mole of solvent over the moles of solution. The values already solved in number 6, so just substitute it. 44.44 mole over 44.587 mole is equal to 0.997. If you notice, the mole fraction of solute plus the mole fraction of solvent is equal to 1. Now let us go to simple stoichiometric exercises. Number 1, what is the molarity of HCl solution if 7 ml of the solution is titrated with 26.4 ml of 0.17 m sodium hydroxide solution? HCl plus NaOH to produce NaCl plus water is what we call neutralization reaction. Before solving, we have to check whether the equation is balanced. This is already balanced. So to solve for the concentration of HCl is equal to MvHCl is equal to MvNaOH. Substitute the values. The concentration of HCl is equal to 0.641 m. Number 2. What is the mass of hydrogen gas produced when 36.5 grams of sodium reacts completely with water at 25 degrees Celsius and 180 m? So the reaction is sodium plus water will produce sodium hydroxide plus hydrogen gas. First, you have to balance the reaction. So the balanced reaction is 2 moles of sodium will react with 2 moles of water to produce 2 moles of sodium hydroxide plus 1 mole of hydrogen gas. So, to solve for this reaction, you can use mole-to-mole ratio. So 2 moles of sodium will produce 1 mole of hydrogen gas. So 2 moles of sodium hydroxide, 2 times 36.5 grams over 23 gram per mole is equal to X gram of hydrogen gas over 2 grams per mole. So the mass of hydrogen, to transpose 2 grams per mole to the left or make it this way, so X gram of hydrogen gas is equal to 2 times 36.5 grams over 23 grams per mole times 2 grams per mole is equal to 6.35 grams. Number 3. How many moles of ferrous oxide will be produced when 4 moles of oxygen react completely with a mole of ferric sulfide? The equation is ferric sulfide plus oxygen will produce ferrous oxide plus sulfur dioxide. So, to solve this problem, we need to balance the equation first. Balanced chemical reaction is 1 mole of ferric sulfide plus 4 moles of oxygen will produce 2 moles of ferrous oxide plus 3 moles of sulfur dioxide. So in the problem we're in, 4 moles of oxygen reacts completely with a mole of ferric sulfide. It will produce 2 moles of ferrous oxide as shown in the balanced chemical reaction. Number 4 is the same question with number 3, but this time, instead of 4 moles of oxygen, we have now 10 moles of oxygen. So we will use the same balance equation, wherein 1 mole of ferric sulfide plus 4 moles of oxygen will produce 2 moles of ferrous oxide plus 3 moles of sulfur dioxide. So, 4 moles of oxygen will produce 2 moles of ferrous oxide. So what if 10 moles of oxygen, how many moles of ferrous oxide will be produced? We just multiply it by 2.5. So 10 moles of oxygen will produce 5 moles of ferrous oxide. Number 5. If 4.26 moles of water were produced after combustion, how many grams of acetylene reacted with oxygen? The reaction is acetylene plus oxygen will produce carbon dioxide plus water. To solve the problem, the reaction should be balanced first. 2 moles of acetylene plus 3 moles of oxygen will produce 2 moles of carbon dioxide plus 2 moles of water. In the relationship of acetylene and water, 2 moles of acetylene will produce 2 moles of water. So, if 4.26 moles of water was produced, so 4.26 moles of acetylene was consumed. So the problem can be solved by the formula mole is equal to mass over molecular mass, wherein mass is equal to mole times molecular mass. So gram acetylene is equal to 4.26 times the molecular mass of 26 gram per mole is equal to 111 grams. Number 6. What mass of carbon dioxide is produced when 27.3 grams of octane was combusted? The equation is octane plus oxygen will produce carbon dioxide plus water. First, we have to balance the equation. 1 mole of octane plus 25 over 2 moles of oxygen will produce 8 moles of carbon dioxide plus 9 moles of water. But we have to have a whole number coefficient, so you multiply the reactants and the product by 2. So 2 moles of octane plus 25 moles of oxygen will produce 16 moles of carbon dioxide plus 18 moles of water. To solve this problem, we need to know the relationship between carbon dioxide and octane. In the balanced chemical equation, 2 moles of octane will produce 16 moles of carbon dioxide, or 1 mole of octane will produce 8 moles of carbon dioxide. So in the problem, we need to solve for the mole of octane, which is equal to 27.3 grams over 114.23 gram per mole is equal to 0.239 mole. The mole of octane now will be used to solve for the mole of carbon dioxide. So 0.239 mole octane is equal to x mole carbon dioxide. So x mole carbon dioxide is equal to 0.239 mole octane times 8 moles carbon dioxide over mole octane is equal to 1.912 mole carbon dioxide. So the mass of carbon dioxide is equal to 1.912 mole times the molar mass of carbon dioxide, which is 44 gram per mole, is equal to 84.2 grams. That is all for today. Try to do these exercises on your own. I am ending this short discussion by encouraging you to be proactive. If you have comments, feel free to contact me on the following medium of communications.